All right, moving on to our next example, we're going to take a look at Aston here, and that will lead us to some more theorems or properties that we can talk about. So Aston measures the diagonals of his deck frame and find that they are congruent. Will the deck be rectangular? So you can see we've got the framing of the deck. The next step, once this is all set, is probably placing the boards across the top and securing those, and that's how you're going to have that deck. So we're just looking at the frame of the deck. Question is, will this be a rectangular deck? And we do know that the diagonals are congruent. So if we notice, we've got opposite sides congruent, 8 and 8, 10 and 10. So that means we are working with a parallelogram. So let's just make note of that. The opposite sides are congruent. So this is a parallelogram. So now the question is, what kind of parallelogram is it? Just your standard run-of-the-mill parallelogram? Or is it more specific to where we can actually call it a rectangle? That's what they're asking us. To show that it's a rectangle, we need to show that the angles are right angles. So it's helpful to write some of this down just so when you go back and look at your notes, you can see what we were doing. So that's what some of these side notes are for. To show this is a rectangle, we're going to show that the angles are right angles. All right, so if we take a look at the frame of this deck, I'm just going to go ahead and redraw. I am going to go ahead and label A, B, C, D, so we can reference those when we need to. Let's see what we know. We know that the opposite sides of this parallelogram are congruent. So AD is congruent to BC. Those both are 8 feet. AB is congruent to DC. Those are both 10 feet. And we also know that the diagonals are congruent. So if I were to draw in one diagonal, that's going to be congruent to the other diagonal. Oops, put that on the same one. All right, so what we just created are actually two different triangles. We can see this triangle ADC is one of them. The other one is triangle BCD. So do you guys see those two triangles? Those two triangles are actually congruent because all three sides we just marked congruent in both of those triangles. So we can say that triangle ADC is congruent to triangle BCD. That's true by side, side, side. And then because we have congruent triangles, all the corresponding parts will be congruent. So we're going to focus on angle D will be congruent to angle C. That's true because of CP, CTC. Okay, so we have a parallelogram. We know that this angle D right here is congruent to this angle C. So those angles are congruent. So angle D and angle C are congruent. And they are supplementary because those are consecutive angles in a parallelogram. We've already determined this is a parallelogram. So those are going to be supplementary. Well, if you have two angles that are congruent and they add up to 90 degrees, these angles must be right angles. So that information right there tells us that angle D and angle C are right angles. And if we look at the picture, if D and C are right angles, and this is a parallelogram, we know that those opposite angles will be right angles. We know consecutive angles will add up to 180. So guess what, everyone? We have a rectangle. So will the deck be rectangular? It sure will. I think that's what they wanted. All right, so let's just run through a couple quick little properties here. If the diagonals of a parallelogram are congruent, so again, let's just draw in let's show that this is a parallelogram, opposite sides parallel. If the diagonals are congruent, so here's, well, let's also label W, X, Y, Z. So we can see that WY is made up of the same two congruent segments as XZ. So those diagonals are congruent. That will make this a parallelogram. So that meant that will make this a rectangle. So that means that angle W, angle X, angle Y, angle Z are all right angles. All right, if the diagonals are congruent and perpendicular to each other, then the parallelogram is a square. So again, this is a parallelogram. You have congruent diagonals. That makes it at least a rectangle, right? But if those diagonals are also perpendicular, that's going to make this a square. If this is a square, that means we have 4 congruent sides. That is what makes a square different from a rectangle. So we know that, oh, we didn't even label our sides. Here is A, B, C, D. So that means that our sides are congruent. AB will be congruent to BC, which is also congruent to CD, which is also congruent to DA. All right, last one. If the diagonals of a parallelogram are congruent and bisect each other, then the parallelogram is a square. I said that wrong. Let me reread it. If the diagonals of a parallelogram are congruent, so look at these diagonals. We've got this diagonal is made up of 2 congruent segments. This diagonal is made up of the same 2 congruent segments. So our diagonals are congruent, and they bisect the angles. So you see how this diagonal is bisecting this angle, giving us 2 congruent angles. This diagonal is bisecting the angle over here, giving us 2 congruent angles. Then you will have a square. When you have a square, that means that you have 4 congruent sides. And we did not label the sides again. I keep forgetting that part. I don't know why that wasn't printed in. Why don't we do W, X, Y, Z? So if this is a square, that means that all 4 sides are congruent. So WX is congruent to XY, congruent to YZ, also congruent to ZW. So again, in this case, you have congruent diagonals, and then a diagonal is bisecting the angles. Then you're going to have a square.